Great, so hello again. I'm Ivars. I'm working for a company called Adaptive Consulting, which is mostly London-based fintech consultancy. We do a lot of systems for different financial players, and one of the things the founders of the company have decided already years ago is that reactive extensions is actually a great way how to build systems which are basically reacting, pardon the pun, to various things happening. And today I'm here to spread a bit of knowledge, spread a bit of gospel about reactive extensions. Because I think myself that they are a cool thing. They probably are not getting as much love as they should get, but well, maybe it's because they're a bit complicated at some moments, but I'm going to try to dispel a bit of this idea that they're complex and give you a very quick introduction on what it is and how it's used. So, what are this mystical thing called reactive extensions? Here I got several definitions from different places, different resources. First two are coming from the official Reactive Extensions site, where they say that it's an API for asynchronous programming with observable streams, which doesn't actually say a lot. I like better their tagline, where they say, okay, this is the observer pattern done right. I was thinking about adding a diagram about observer pattern from Gang of Four or something like that, but I looked at it and I was like, damn, this thing is too complex. I'm not going to try to understand it, and somebody's going to ask me questions about how it's related, and I will have to think and find a way, and so I'm just skipping that part. If you look under the hood, it's basically just a library implementing two interfaces called iObservable.lv and iObserver.lv, and various utilities around them. And the last one is how I like to think about them. They're basically either push-based sequences or asynchronous sequences. So if you're working with .NET, you probably are familiar with enumerables, which are pull-based sequence, where you basically ask, okay, give me next value. Observables are exactly the opposite thing. It's about saying, okay, I got a value for you, do something with this value. And you could say they're asynchronous as well, also it kind of gets a bit tricky when you get there. And here you can see my take of trying to be funny. So as I said, as I'm calling this, it takes two interfaces to tango. But as I said, most like the fundamentals of reactive extensions are built around two interfaces. First one is iObserver, which defines something which observes things happening. And it has three methods on it. On next, on error, and on complete. When things happen in observable land, somebody calls those methods, say either that, okay, I got the next value, do something with it, or, sorry, I encountered something bad, here's your exception. Or when thing which produces values knows that, okay, we are done, there's nothing more going to happen, no values at all coming, it calls uncompleted. And the implementation of this interface is passed to the observables method, subscribe, which basically says, okay, there's this thing, interested in the values you are having, or you are going to produce at some point in time. So please take this thing and gives values if you have them. The interesting thing is that it returns iDisposable, and I'm going to touch it a bit later, but maybe keep it somewhere in the back of your minds that there is this iDisposable thing coming. Having those things defined, you have an explicit protocol how the observable thing works. You can get explicit values, which is signaled by calling onNext one or several times, depending on the amount of values you have. You can actually explicitly say, sorry, I'm not going to have any value at all for you, which is signaled by calling onCompleted without calling any onNext calls. It basically says, okay, this sequence is going to be empty. We are not going to produce any value. Or you can get explicit failure calling onError. You can get it as a first call, which means, okay, you subscribe thing and it just errored. You can get it somewhere in middle, but that's more of like next case, when you can get a termination of sequence via onError or onCompleted call, depending on what happened. Did the sequence errored, or it actually is done and there's nothing more going to be produced. And then you have explicit cancellation, and this is where this iDisposable on the previous slide comes in. In the .NET world, they decided to implement this cancellation through iDisposable because that kind of fits nicely with all the language facilities. You can use using blocks and so on. It's actually not the case in other implementations, which is something I forgot to mention earlier, is that you can get reactive extensions not only in the .NET world, also it started there, but there are implementations for, I think, all major languages. Like if you go to their site, you will see that there are probably 20 implementations, Arins Java, Arins JS, Arins Scala, whatever comes in your mind, it probably has got it. And in the languages where you don't have iDisposable or something similar, there is some other mechanism used for it. For example, I think it was for Java, where it was returning a specific object called subscription, which you can then use to unsubscribe. But as I mentioned, in .NET world, you just get iDisposable and dispose it when you are not interested in this subscription anymore. So the observable knows that it doesn't have to pump the information to this particular subscriber anymore. As disposables are such an fundamental concept in Reactive Extensions for .NET, actually the Rx library comes with a bunch of, let's call them helper types, the disposable types which facilitate easier using of them, and when we'll get the code samples, I will try to show some of them as well. This is the explicit part of the Reactive Extensions protocol, and there is an implicit part as well, which is not defined strictly in code, but those are kind of guarantees you expect it to have. If you have a well-behaved observable, it should make sure those guarantees are in place. There are only two of them, and first one says all the callbacks are actually serialized, so you are guaranteed that the data is going to be pushed to your subscribers in the same order it's generated, kind of always. There are some caveats to that which we will touch a bit later. This one I'm not saying it's always, but kind of always. And you're going to have only a single onError or onCompleted call coming from your observable. If you get onError call, if your implementation of observable calls on error or on completed. It shouldn't call any on next or the same on error on completed anymore. As soon as you get one of those calls, the sequence is terminated, nothing else should be produced on that particular sequence. How to create one? We are getting closer to the code, so bear with me a few minutes, we will get there. It's not just going to be reading from the slides, I promise. One thing you could do is take those interfaces and implement them explicitly. Please don't do that. I don't think there are a lot of use cases when you really should implement your own observable. There might be some. I have been working with this stuff for quite a few years already. I have never seen one when you really needed to implement your own observable. You might do it as an exercise when you are learning about them, but don't do it outside of learning experience. Then you have a bunch of factory methods in the library. Those are the .NET ones. In other implementations, they might be called somewhat different, but still the basic idea is similar. I'm not going to go through all of them now because I believe all of you know how to read. And this is actually mostly copy-pasted from the Reactive Extensions website. And I did some slide formatting on top of that. But what you can see here, you have like methods which create just observables where you pass methods how to generate the sequence, which are basically the first two, create and defer. Empty, never, and throw are very exact ones, which basically says what is the name that does it, like empty one is an empty sequence and so on. The from section, that one is a bit interesting because there is not, at least I don't think there is, a method called from on the API circuit, but it's a bunch, it's kind of a group where you have different methods which are used to convert something else into an observable. The interesting ones particularly are the ones about creating it from events. So you can basically take an event subscription coming from another component or something and just say, okay, those events actually want to turn them into a stream of data coming through. And it's very powerful because if you think about it, an observable is basically a sequence of events happening in the component in some part of your system you are building. What I also would like to point out are methods called interval and timer, because the naming there is a bit confusing. When we think about timers, we think about something which executes after a given period of time and repeats. But actually a timer creates an observable which emits only one element after a given period of time, and the interval one is the one we kind of would think about more like as a real timer. And other ones are probably not that interesting. I'm quite sure that this list is incomplete. Like if you start going into, I don't know, Visual Studio or whatever is your ID of choice, type observable and dot, and you get IntelliSense, you will get probably twice as many of those which help you creating them. Okay, now it's time for me to stop reading slides and show you some code. Let me just quickly switch to my trusty link pad. Okay, it's not showing. Okay. Mouse over there. How many of you know what is link pad? Okay, quite a few. Ones who don't, I really suggest to looking it up. It's a wonderful tool to just play around with some smaller snippets of code, much more lightweight than Visual Studio. it has its drawbacks in comparison because it's a simple tool, but it's great for demos and things like that. So what you see here is a sample I prepared, which basically has shows how to use the observable create method. You have it, you call it, you pass a delegate which says, which takes, which takes observer as a parameter, and what you do inside it, you basically call those three methods I mentioned earlier, on next, on completed, and maybe on error, to signal what's happening. And as I mentioned, you have to return disposable, which is kind of used to control the subscription. And here you can see as well the use of those disposable helpers. This one creates a very handy disposable, which basically calls an action you pass to it when it's disposed. And after creating one, I'm subscribing to it. If you look at those dump methods, it's a linked helper which basically outputs the value. So let's see what happens. As you see, it should generate 10 values and pass them. Let's probably do it faster than once per second. And if you run it, you see that it gets consumed here. So basically, if you think about it, the whole premise of the reactive extensions is that something happens somewhere, or maybe it's better to say, there are a lot of things in a row happening somewhere, and when each of those things happen, there is a piece of your code which reacts to one of those things. Another plug for linkpad is that it has this handy dump latest extension method, which is very useful when you are working with observables. It just dumps the latest value of the observable. But it depends a bit if you want to use it, because in different cases you might want to actually see the whole sequence, not only the latest result. And let's get back to the slides. I guess that's this one. Creating a sequence is a cool thing, but actually you shouldn't do that much. You probably are more interested into consuming them, which is kind of simple. You just subscribe to it, get your value, do something with the value, and forget about it. But more often you actually have to combine several sequences together, like, I don't know, information coming from your messaging queue that something happened, users clicking on UI parts, buttons, drop-downs, whatever. You can think about all those things as streams of as different streams of events, which then you have to combine in some way. Those are four kind of groups of how you can combine them. Again, I don't think it's a full list of ways how you can do things, but those are the ones you probably would run in most often. The first group is just manipulating it, kind of single sequence things, if you really squint and look at it that way. So the concat one takes several sequences actually, and when one of them finishes, it just takes the next one and adds to it. Which is a very interesting point here, as you have to remember that finishing sequence is something which might never happen. Your sequence might be that it never yields on completed call, and you basically have like infinite sequence. Also, it might not emit items on it, so you have always be careful with things which kind of expect your sequence to be finished. It might backfire in unexpected ways. Repeat one is somewhat similar. It just takes one sequence and repeats it either indefinitely or given amount of times. So it emits something like, I don't know, 1, 2, 3, then it calls on completed, then it subscribes to it again and expects it to emit all those things again and again. And start with is something interesting because it's actually not combining sequences, but it allows you to prefix your sequence with some arbitrary values. Merge, switch, and am are the ones which kind of controls flow from several sequences. Merge basically takes all the events coming from like various sequences and just funnels them together in a single sequence. Switch switches to the sequence which emitted event last and then continues on that, ignoring the previous one. And AMP is somewhat the opposite because you pass several sequences to it and it actually yields the results of the one which has the first result coming in. Combine latest and zip are very often used for combining two sequences together. I guess zip one should be pretty familiar as it's the same concept as in, let's say, enumerables, when you just take entries together and pass and pair them and pass them through the pipeline. Combine latest is somewhat similar but different because zip expects both sequences to yield one item to form the next pair. Combine latest actually needs only one of the sequences to yield an item, and then combines latest items from both sequences and passes it through. And when then, honestly, I added it to the slide just for sake of completeness. I have no idea how it actually works, but this is kind of the way how you can build your own combination operators, and it's like the most flexible nuclear option they're having, but it's also something I have never seen in my life being used in production code. It has its uses, I'm pretty sure, but I haven't seen that. In addition to all this, you can do pretty much all stuff you can do is regular sequence with enumerables in link, with observables as well. You have your vares, no, actually it's called filter. You have your accumulation, you can scan over the sequence, you have a bunch of buffering functions for grouping things together on the same sequence to do time-shifted things. I'm not going to go in depth with those things, just because, like, you can go to their site and see this. It's not really interesting. I think like the combining part is much more interesting than just mutating the data you are getting in the sequence. And it's time for another demo. And this one will be about combining sequences. The setup is simple. There are 3 sequences emitting some things on different intervals. So if you see, like first 2, they basically have one is a bunch of numbers, another one a bunch of letters. Another interesting thing to see here, you actually have to subscribe to the sequence to get the result from it. But there is no subscription because LinkPad, as it's like debugging, playing around this code tool, it includes that in the dump itself, that it subscribes to it and then dumps the result. But we are not interested in this one. Let's see just examples of what happens when you, for example, concat the sequences. So you can see, as I said, it first goes through the first sequence, then adds the second one. You could actually concat it further with the third one if you wanted to. Another thing I didn't mention, but which you probably should pay attention to, is the take operator, which basically helps you to terminate infinite sequence after you get a given amount of items from it. So the first one is generating 6 items, the second and third one is giving 3 items each, which is mostly to demonstrate the differences between combined latest and zip and things like that. Repeat one, again, not really a rocket surgery. You get the sequence repeated. Start with just add the items, as I said, and the point at which you probably should pay attention here is that you see that they're emitted immediately. So the on-next are called immediately. Also the sequence itself, the next items it generates, is generated in 1.5 second intervals. Which really shouldn't come as a surprise, but just something, again, to not forget and to remember that such thing is happening. Merge. What was merge doing? Merge was the one which was taking items from the sequence as they arrive and just emitting them in a single sequence out. So you see, as they are with different intervals, you get first 4 items from the first sequence, then you get first one from the second sequence, and so on. There might be a slight non-deterministic behavior, because you can get race conditions that 2 of the sequences are emitting the item at the same time, and there are no guarantees on their ordering. But in most cases, it's probably not really interesting thing. So here I'm doing something crazy, and you are actually getting an observable of observables. You can nest them, and this is where the switch statement comes in handy. Because it helps switching to, as I said, it switches to the inner observable, which produces the last value you are getting. Yeah, it sounds confusing even to me. So, sorry, I have my call. So you get, as you see, initially you get the items from the first nested one, then the second one starts generating, you get from the second, and so on. And it's all merged in the same, like in a single sequence afterwards. Another operator, which I didn't mention, is select many one, which is the same thing as in regular sequences in enumerables, which basically takes one sequence and like one value and selects many values in the same sequence afterwards, which is basically a way how to join the multiple. If you have observable of observables, it's an easy way how to actually merge them together in a single string. And then there are those funny things I mentioned. So the AMP, which gives you the first sequence emitting notifications. The zip one, which takes 2 sequences and puts them together. So let's see. You can see that even if the first sequence is actually emitting notifications at very short periods of time, you still had to wait for the first one to happen because it was waiting to have a matching item on the second one. And then you have the combine latest, which, as I said, it works a bit different, and I think you will like this example helps to understand it quite good. So you don't get that on the first sequence, the first 3 notifications are missed because the fourth one it managed to go through 4 ticks of them before the second sequence emitted its first item. So it took the last one on that period of time on the first one, added the second one. As the first sequence kept emitting things, you see it still gets paired with the second one, with the same item you got from it. And even when the first one is finished, you still get the last values combined with the next items coming from the second sequence. And if you did something like, let's see, let's start the second sequence with some item just so it has emitted a notification. You see, it gets this first emitted item out, which is empty, and concatenates it, joins it with the items coming from the first sequence. And the duplications there, it's probably a bit racy as well because they just happen to be emitted at the same time, or not. I actually haven't paid too much attention on the timings there. And this is also a good strategy when you want to have this kind of combined latest semantics, but you have no guarantee that both of your sequences are going to yield early enough. Like one of them might be slow producing one, which emits something, I don't know, every few hours, but you want to get the combined result. So you can just prefix it with, start with whatever is your representation of empty value and get it down the road. The other thing is I'm using here 2 sequences, but actually you could combine more than 2. You just need a proper combinator. And then, so here you see what happens when you combine all 3 of them. Again, we probably should have left that empty start here. Real world scenarios, as I mentioned, it could be like some data coming from a messaging queue, user interaction, and so on. You want to combine them together, like, okay, this is my latest database information, and I want to generate this report on this. You can join those 2 streams and then just pass it to some kind of dispatcher which does this thing based on both items, and you don't have to really think about pulling that data in when you need. It's actually pushed to you when it's required. I have to briefly touch the topic of subjects, but again, something you probably are not really going to use. There are things, there are classes which implement both observable and observer, so they act kind of as a gateway between them. They're great for the internal implementation of some things which are required for Arins, but you don't, again, outside of playing around with reactive extensions, you don't really see them a lot in the wild. Also, once in a while you, like, if you should never implement your own observable subject, you probably might use at some moment. There are 3 ones which are 3 predefined ones besides the generic subject, which are replay subject, behavior subject, and async subject. And they're mostly used, as I said, internally to get some behavior which I will touch a bit later. So I will just quickly show how they look in the code. Completely made up example because, as I said, you shouldn't really be using them. What we do here is create just subject which are going to produce string values. We subscribe to it by saying that when the value is produced, just dump it on the output, and then we use it in a sense of we use it as an observable, as an observer, and call its on next and on error method at the end. So, as I said, it's acting both as an observer and as an observable. Like, one situation that I can imagine you would like to implement it if you would like to add some kind of side effect to it, but honestly it's much easier to implement using kind of standard things in Reactive Extensions and writing your own subject. So as I said, I'm mentioning it here just for sake of completeness. I don't think it's really interesting thing to focus yourself on when you're dipping your toes in observable world. This definitely is more interesting topic than subject. Hot versus cold observables. When we call observable cold, a cold observable basically is an observable which starts producing values only when you subscribe to it. And most, well, maybe not most, but quite a lot of observables you're going to work with probably are going to be cold ones, because you don't care about the values unless you subscribe to it. Hot ones are the ones which produce values even when you are not subscribed to it. I don't know, like time itself is kind of hot observable, like time ticks even if you don't look at it. Also, some philosophers might not agree with that. Timers, they seem to be hot observables if we talk about time, like if you look at them kind of from our notion of time and so on. They actually are cold ones. They are not running unless you subscribe to them. What else could be hot observables? Like user interaction probably with the system. Like user, I don't know, mouse movement coordinates, for example. User moves mouse around even if you don't observe it, pardon the pun. So it kind of is producing the values. So those are the two different types, and you actually sometimes, or quite often, want to convert the cold observable to hot one, because you want things to come in already, like things are happening. And to do that, you actually have to do two things. You usually call publish to convert it to connectable observable. And that reminded me actually, there's another reason why you want to have a hot observable. Or, it's because cold ones, they always generate, like each time you subscribe to it, they start from the scratch. So if you have the same observable, you subscribe to it twice, each of the subscribers are going to get different, or the same set values, but kind of on a different rate. So you publish, converting it to connectable observable, then you call connect on the connectable observable to start producing values, and at this time you don't even have to be subscribed to it, it starts producing values. And then every subscriber which connects after you have started your observable is getting the values from that point of time it connects to it. And I will show sample in really short moment. which will probably make it a bit clearer. Then you can use, instead of after publish, you can use ref count to get the behavior which is often deserved, which basically creates a connectable observable which gets connected as soon as somebody subscribes to it, and then disposes the original observable as soon as you don't have any subscriptions left, so automatically disposes it. Which, as I said, unless in some library code, it's probably exactly the behavior you want from your observables, in most cases. Publish last is somewhat specific way. It's similar to publish, but it actually doesn't produce anything till the sequence completes, and then publishes only the last value from the sequence. So it converts it to something similar to the task. Replay, that's very valuable thing, which basically says, okay, every time a new subscriber subscribes to this connectable observable, I'm going to replay all the values which has been so far, or which has been in some defined window from this point you connected to it, to the new subscriber. So if hot observables are kind of losing the values, you actually use replay to keep those values saved for the new observers. And some of you might have noticed that it's actually, a few slides ago we had a replay behavior, and that's basically what's used kind of to get this replay subject, sorry, used to get this behavior. And multicast is a generic version of those things I just described. It basically, you can pass subject to it and get the expected behavior. So replay is calling multicast with passing replay behavior. Publish last is with async behavior, async subject or not. Okay, it's actually not, it's more like kind of previous thing, so it's not that important. Another demo about hot and cold ones. Let's try to keep it short. This is a cold one, and you see that you get, as you subscribe to it in different times, they're kind of getting different values as it's time-based one. And if you make it into connectable one with publish, and then connect it, you will see that both subscriptions are getting the same values, and as the second one subscribed later in the life cycle to it, it's getting less values. So if we change the publish to another thing is you can play around with connect to control how the sequences are getting their values. For example, if you put it like this, both sequences are going to get the same values as it's subscribed kind of immediately out as it's connected. So you get a bit of flexibility how your subscribers are getting values. Also, it's usually not that useful at the end. So if you do the replay here and connect it, and maybe let's move, let's add some weight here. Just do this one value. You see that they are still getting all the values because, as I said, the replay one is caching the values for the further use. Or if you you could play around with saying that you want to cache only the latest value, not all of them. Well, basically it's something you play around to get the behavior you expect from it. Threading, when it comes to reactive extensions threading, there are a few misconceptions. Well, there's one big misconception. People tend to think that the observables are multi-threaded, but they are single-threaded by default. You use observe on and subscribe on methods to kind of change the threading model, how they are, how the sequences are generated and consumed, and that's where the schedulers come into the play, because that's something that's another interface which is used. So I lied to you a bit when I mentioned that it's built only around Observable and Observer. And schedulers basically are things used to schedule the execution of the values as they are produced. There are many different ones, like you can say, okay, let's use thread pool to schedule the generation, or let's use the current thread and things like that. The interesting one here is the test scheduler, which is basically a scheduler you use to, where you can have complete control over the time. So in your test, instead of having to wait, I don't know, 5 seconds for interval notification to come up, you can actually pass a test scheduler instance and then just say, okay, my test scheduler, you have to advance 6 seconds, and then you can assert on what's happening. And if you talk about threading, you have to be very careful, because mixing observables with async methods or async functions actually in most cases are going to break the implicit serialization guarantee. What you're getting is that your tasks are created serialized, in a serialized fashion, but as they are passed for execution to other threads in most cases, the completion of the tasks are probably not going to be serialized. And it's another demo time, which is about mixing tasks and serialized observables. Sorry. So what we have here is my favorite interval observable, because it's really convenient for demoing. And then we are selecting from the generated notifications a get value calls, which are nothing very interesting, just basically task which simulates some work happening over some time. And if you run it, you see we are getting here a bunch of tasks, and also they are starting in an order, they are completing in a completely random order. You can get around this in several ways. Like one thing which comes, there are several overloads actually around those things which help you to combine observables and tasks. So for example, select many actually has an overload which takes task and generates the value, awaits it. So if you see, look at it now, you can see how it's filled up. Well, maybe let's do it so you can see better. It starts to fill up as tasks are being completed and they're still out of the order. You can use, instead of select many, the same select, and then concatenate it, which will seem that they're executed in the order, because what concat does when it gets observable of tasks, it waits for the first one to complete and then waits for the second one to complete. So they are kind of serialized, but if you look at how the tasks themselves are happening, you see that they are still done out of order. The thing which I found out to be working, at least in LinkPad, I'm not that sure. I haven't investigated it deep enough to make sure that it works on the code base outside, is by saying that let's schedule the subscription on current thread. So you can see now the tasks are waiting for the previous one to pass because they are scheduled in the order, and the next one is not started really before the first. No, they're not actually. So what did I do wrong now? I swear you, it worked when I was playing around with it before this. Worked on my machine, well, in my office. Still doesn't work. So I think it's a good proof that getting things right when you mix observables with tasks is really hard. I have been working, like, I'm not the expert on observables. I know about them, I've been working with them. I have worked with people a lot more experienced with this stuff than I am. And like, they keep surprising me about how powerful they are and about how many gotchas there actually are when you go into all corners of it. So, yeah. But everybody says mixing observables and tasks is actually a recipe for disaster. And I proved it just now. There are a few resources which I mostly use to compile this talk. Intro to Arix.com, that probably should be the first resource you go for if you want to learn about them. It's a free ebook by Lee Campbell, the guy who used to work in our company ages ago, and he probably is the expert on reactive extensions, and he explains all this stuff probably much better than I did, and well, it will take you much more time than it took now to explain it, to get all this. The second one is the official site. The third one is community maintained wiki with a lot of examples for, let's say, recipes for for a particular use case. And ericsmarbles.com is a place where you can play around with JavaScript implementation of reactive extensions. And what it does, it draws those nice marble diagrams which shows how sequences interact and are combined. And it helps you to visualize how your combination turns out in the end. Thank you for listening to my rambling so far. Down in that corner, that's my Twitter handle. But I'm actually not posting a lot about software development, so if you decide to check it on your own risk. And I guess the floor is open now for questions. Yep.
Could you please comment on the performance impact between dispatching some information and receiving it on the other end? How does it compare to other types of maybe synchronization methods, or what is the latency between dispatching something and receiving it on the other end? Can you use it in like time critical, real-time applications?
Well, as I said, our company is specialized in financial software. I'm not sure if it's like really like I don't remember. I don't think we have built really high frequency trading systems, but a lot of them are time critical ones. And definitely reactive extensions are fine for that. Of course, it depends on the schedulers you are using, what is the model. Like when you get to the time critical, you might start to think about like really into what is the strategy to use there, instead of just relying on the default ones. But it's definitely low latency because it's in process anyway. Like you will get some synchronization overhead, of course, but I don't think that in most cases people should be worried about it. Like if you get to the ones where you really need the last microseconds, then be careful. But even then, I think it's going to be fine. But I don't have any numbers to prove that.
So no more questions? So thank you.